Okay, so today's review is going to go over graphical models. So we want to have our comparisons between our linear functions, our quadratic functions, and our exponential functions. So when we look at a linear function, an equation is in the form y equals mx plus b. That is where m is your slope, b is your y-intercept. Now at the graph of a line, we can have something that has a positive slope with a negative slope. We can have a vertical line. We can also have a horizontal line. And if we're looking at a table of values, if we find the first differences and those are the same, that means we have a linear function. So our first differences are the same. Okay. Next, looking at our quadratics. This is a parabola as graph. This is in the form y equals ax squared plus bx plus c. Okay, so where linear has an x with an exponent 1, quadratic has that exponent 2. Like I said, these are in the form of a parabola, so we either have a U shape, and it can have an upward or downward opening. So looking like a happy or sad face. Now when we look at a table of values for these, it's the second differences that are the same. Okay, so when you find the first differences, if those aren't the same, you continue on to try out other options. So if the numbers are the same for the second differences, it's quadratic. Now looking at exponential, we are in the form y equals a b to the exponent x, where a is your initial value, b is your growth rate, and to the exponent x is your time. So we can have growth, or we have a graph that is a decay. Okay. So here we're not looking at subtracting between our table of values. We are actually going to be dividing from one to the next. So when that dividing has a number that is very close to or the same, so having a common ratio. Okay, so when that common ratio is the same, it is an exponential function. So now looking at specific examples of this, when we look at our different equations, we want to identify if they're linear, quadratic, exponential, or none. So this first one, we have the exponent x. So this one's exponential. Next one over, we have an x squared, making this one quadratic. Next, again, we have an exponent of 2. So this is also quadratic. Our y equals 2x plus 7. We have an x with an exponent 1, so this is linear. Okay, here we do have an x squared, but also we have a y squared. If we notice with our other ones, we just have a y. So when we have a y squared and an x squared, then this does not fall into any of our categories, so that'll be none. Okay, so that on a graph is actually a circle. And the last one, y equals 2 over x. Over x, that's not one of our options for linear, quadratic, or exponential. So this is none. Okay, so next we can look at tables. So we want to look at our first differences, our second differences, and our common ratios. So just by looking at your table of values, you might be able to make a guess to whether it would be linear, quadratic, or exponential, and that's where you would want to start. So looking at our first values, whenever you want to find a difference, you want to take the lower number and subtract the one above it. So -4 minus -7 is 3, and then -1 minus -4 is 3, 2 minus -1 is 3, and 5 minus 2 is 3. So here, our first differences are the same, so this is linear. Okay, looking at this next table of values here, looking at these y values, we notice that we can multiply by 2 to get to the next step. So that means we would want to try out a common ratio here, where we would have 8 divided by 4, which is 2, 16 divided by 8, 32 divided by 16, and 64 divided by 32. Okay, so our common ratios are the same here. So dividing, common ratio, and that gives us an exponential. Okay, looking at the next one here, we're going to try out our differences. So if we did 4 minus 2 is 2, 7 minus 4, 10 minus 7, and 13 minus 10. So here, 3 match, but 1 doesn't. So since that doesn't match, we want to continue on. If we did 3 minus 2, get 1, 3 minus 3, 3 minus 3, 0. Okay, so also not matching. And if we divide it here, 4 divided by 2 is 2, 7 divided by 4 is not 2, so those are also not matching. So this one is none. And last, let's try to find our differences again. So 9 minus 4 is 5, 16 minus 9 is 7, 25 minus 16 is 9, and 36 minus 25 is 11. Those don't match, so it's not linear. Going on to our second differences, 7 minus 5 is 2, 9 minus 7 is 2, and 11 minus 9 is 2. Because our second differences match, we can say this one is quadratic. Okay, so now we are going to look at our graphs. So again, still looking at our options of linear, quadratic, exponential, or none. The first one we have a horizontal line. This one's linear. The second here we have a parabola, so it's quadratic. Now this third one, it looks like a parabola, but it's turned on its side. So because it's turned and it's not a happy face or a sad face, this is actually going to be none. Okay, those quadratics are specifically with an upward or downward opening. Looking at the next one is exponential. Then we have a circle that doesn't fall into any of our categories, so that's none. And we have a vertical line here, and this one will be linear. Okay. Now, another thing that we're going to look at is rate of change. And a rate of change in a table is rise over run. Okay. So the rise is your y value, your run is your x value. So with a table of values, it's not always going up by the same amount in the x every single time. So that's something that we want to consider. So looking at this first table, these are going up by 1 each time, the x values. The y values are going up by 3. So our rate of change is our rise over run, and that's 3 over 1. Over 1, which gives us a rate of change of 3. Okay, and the second table, again, your y is always your rise, your x is your run. You want the differences with your y's, the differences with your x's, and then you can find your rate of change, which is also the slope. Okay, also the slope in your equation. So the change in our x here is 2. And our change in y is 4. So our rise over run is 4 over 2, which gives us a rate of change of 2. Okay, so the last thing we're going to discuss for this unit is rearranging a formula. So when you're given a formula, you might have to solve for a variable that is a part of the equation and not isolated. So in a question, you could be given volume and height and need to find the radius or any combination. So we need to be able to rearrange the formula. So this first one is asking us to solve for h. So when we have v equals pi r squared times height, what we have here is pi times radius squared times height. So when you bring something from one side of the equation to the other, you're doing the opposite operation. Since we have a multiply here, when we bring it across, we're going to divide. So we'll have v divided by pi r squared equal to the height. And the second one, it's asking to solve for r. So we have the v equals pi r squared times the height. Again, when we move the multiplying, it goes across and it's divide. So v over pi times height equals r squared. And then to get radius by itself, you want to do the opposite of squared, which is a square root. So we have the square root of v over pi times height equals the radius. Okay. When you're rearranging a formula, it's important that you are moving things in the order of SAMDEB. So if there's adding and subtracting, that goes across the equals first, then you're multiplying and dividing, then your exponents, and then your brackets. Okay, so you have a couple of worksheets that you can be doing to review this unit, and if you have any questions, please let me know.